This video is over lesson 30, graphing functions, from my Algebra 1 class. So ladies and gentlemen, graphing functions, today we're going to be introduced to a new type of notation which when we first are introduced to it can be a little confusing. And it looks like this. And you've been trained to look at this and say, all right, f is a variable, x is a variable, so this is f times x. Unfortunately, you'd be wrong. This is what's called function notation. Function notation. And instead, the f out here is actually the name of the function. And we often name our functions f, just because f stands for function. Though you don't have to. There are plenty of other letters that get used from time to time. Whereas x then here is the input or independent variable. So in this case, the parentheses, unfortunately, this isn't really communicating multiplication. You need to almost imagine that the parentheses are like an incomplete basket, like the rim of a basket, where you're sticking values into this function. And the function itself is like a machine where it takes what gets stuck in, does something with it, and produces a product out on the other side. We would read this as f of x. Now, I'm going to tell you that in this case, we're going to keep things real simple to start with. We're going to say that f of x equals x. So by making this into an equation, I am telling you now what this function is doing to my input value. So in particular, this one actually isn't really all that exciting, because if I put in x into the function, I get out x as an answer. And so we're going to make a table of values for this. Let's come over here, and I'm going to have an x column, and then I'm going to have an f of x column. And let's go down about, let's give ourselves about 5 spaces there. I'll get that out of my shadow there a little bit. So, and let's put in the values -2, -1, 0, 1, 2. Now remember, what makes this the independent variable is the fact that I can go ahead and choose the values that I'm sticking in here. So I've chosen these values. These are the ones I decided to use. Let's see what comes out. So ladies and gentlemen, if I choose x to be -2, then we are thinking about replacing x with -2. So this would actually be f of -2 then. So imagine sticking -2 into this equation. Well, it's a very simple equation, so there's really not much to do. Obviously, if you stick a -2 in, you get a -2 out. So -2, -2. Likewise, if I plug in -1, so f of -1, f of 0, f of 1, f of 2, I've chosen a very, very simple function to start with. If I put in -1, I get out -1. If I put in 0, I get out 0. If I put in 1, I get out 1. If I put in 2, I get out 2. So ladies and gentlemen, when it comes to graphing, if we use a table of values, all we need is enough points that we can find the shape of the graph. Now, this being f of x equals x, we're going to consider our f of x basically to be our y values. So this is almost like y equals x. Well, that's going to be a line. So I have enough points here to make my line. I'm going to come down here. Since the highest values, absolute values that I have is 2, so let's go 3 in every direction here for our coordinate plane, just to give ourselves a little extra space. And as long as I have enough points that I can find this line, we're good to go. So -2, -2, -1, -1, 0, 0 is the origin, 1, 1, and 2, 2, 2, 2. Well, sure enough, I can stick a line through there. Now, if I didn't have enough points, I would just add to my table and get a few more until I can find the shape of whatever I'm trying to graph. Let's look at another example. So skip a few spaces here, and let's come down. And this time, we're going to say g of x. So I'm going to give my function a new name. So instead of f, this function is going to be g. And this time I'm going to define g of x as equaling x squared. So whatever I plug in for x, this is what I'm doing with it. I'm going to be taking that x and squaring it. I'm going to make my table of values here. So I got an x column, I've got a g of x column. And again, let's have 5 entries. So if we have 5 entries here, I'm going to choose the same values. They worked well for me last time. Let's see if they do as well here. A little bit on the positive side, a little bit on the negative side. And so then this is a little bit more complicated, but not a ton. In this case, I'm going to have g of -2, but when I plug that in, that's going to be a -2, and then I'm told to square it. Now remember that because this is negative, when I plug that in for x, I want to square all of x. So I need to put parentheses around to communicate that I'm squaring the negative with the 2. So then down here, g of -1 would be a -1 squared, just like it says to square it. G of 0 would be 0 squared. So that doesn't have a negative sign on it. I don't really need the parentheses. Then I'd have g of 1 would be 1 squared, and g of 2 would be 2 squared. So if I finish this off, -2 squared would be a -2 times -2, so 4. -1 squared would be -1 times -1, so 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So I have 5 points here, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So let's see if this is enough to graph. Now I've got a biggest absolute value here is 4. So it might be nice if we go about 5 spaces in every direction. So if I think about starting my graph maybe like right here, I'm going to drop down 5 spaces, and I'll go over 1, 2, 3, 4, 5. I like to make a little mark, say that's where my y-axis is going to go, 1, 2, 3, 4, 5. And then I can just bring this up to that little mark I made there. Now I'm going to have to count 5 down though, 1, 2, 3, 4, 5. Don't forget your arrowheads. And now we plot our points. So -2, 4 would be up here. -1, 1 would be right there. Again, I have the origin, 0, 0, 1, 1, and 2, 4. So one of the things you'll notice about this graph is it's definitely not a line. Not only is it a line, but if I tried to draw a line between these 2 points, I would miss that point right there. This is actually something special, which we'll look at in more detail later, called a parabola. And it actually kind of has a U shape to it. So it comes in, it's nice and has a nice curve to it, no sharp corners. So it just kind of curves up and keeps going. Something like that. So I am familiar with the shape of that, so I'll let you know right now that is the shape of the graph. We have enough points that'll work. So if it has an x squared in it, it will probably look like that. As long as there's no other x cubed or x to the fourth power, some other higher power, it'll look something like that guy. All right, let's jump down now to our next example. Let's call this function h of x. H of x equals the absolute value of x minus 2. So those are my instructions. When I put something in for x, I'm going to do that x minus 2 and then take the absolute value. So for our table here, let's go with x and h of x. So -2, -1, 0, 1, 2. I have an extra space. That's okay. I didn't quite count that right. Ladies and gentlemen, I'm going to skip the red pen this time. So we do need to still think that through. So h of -2, so we're thinking plug -2 in here. A -2 minus 2 would be a -4. Absolute value, that would be a +4. I plug in a -1. -1 minus 2 would be a -3. And the absolute value would make that a +3. 0 minus 2 would give me a -1. The absolute value of, excuse me, a -2. The absolute value of -2 would be a +2. 1 now, h of 1, so 1 minus 2 would give me a -1. Absolute value would make it a +1. 2 minus 2 is 0, and its absolute value is still 0. Now, ladies and gentlemen, I'm going to help you out with this one. The absolute value should produce a graph that looks like a V. So if I go ahead and graph this, let's go 5 in every direction again. So I'm going to make my little mark here just kind of as a reference point. Come down 5, and then we'll go over here 5, and then 5 more, and up and down 5. So -2, 4 would be right there. -1, 3. 0, 2, 1, 1, and 2, 0. Remember I said just a moment ago that this should be a V. So we find ourselves in a situation where we do not have enough points to find the shape of this graph. So in that case, we extend our table. And no, I was not planning ahead and did that on purpose. I actually did have an extra space on accident. But it works out because I'm going to extend this now. So let's go 3 more values. Let's plug in 3, 4, 5. See if we can find the shape. If we don't find the shape, maybe we need to go a little more in the negative direction. So if I plug in 3, 3 minus 2 is 1, and its absolute value is still 1. 4 minus 2 is 2, and its absolute value is 2. 5 minus 2 is 3, and its absolute value is still 3. So if I plot the rest of these points then, 3, 1, 4, 2, and 5, 3, now we see the V. So we're going to go off in this direction forever, and we're going to go off in that direction forever. And there's my graph. All right, on to the back. I'm going to reset here, and we'll go back to F since we're on the back now. So let's say f of x equals radical x. So remember, ladies and gentlemen, the radical is this nuanced thing that we have to be able to hold in our minds, the fact that this gives us the principal root. This is not a true square root, it just gives us the principal root. So of the two options, the positive and negative root, it gives us the positive. So my table of values here, I have x, I have f of x we'll get a few values here. Now with this one, I kind of want to be strategic about what values I choose to plug in. I get to choose my independent variables. I get to choose those. So if I'm looking for a value to plug in here, since we're going to do a radical of it, do we want to choose a negative? Well, no, because the negative is going to lead to imaginary numbers, which aren't something that we're going to be able to graph. They don't exist in our real world, so we can't graph them. So we don't want imaginary numbers, so no negatives. But if I plug in 0, I'm going to get the radical of 0. Well, that sounds nice. So let's start with that. So since I don't want negatives, let's start with 0. The radical of 0 is 0. Now let's start thinking what would be nice. So if I move on to 1, would 1 be nice? Yes. 1, if I plug in 1 here, radical 1 is 1. Now if I put in 2, radical 2 would be irrational, which means I wouldn't be able to really fit it nice and neatly on my grid. I'd have to do my best guess at where to place it. So I'm going to avoid 2. I'm going to think this through. So if I plug in 3, I'm going to get radical 3. If I plug in 4, I'm going to get radical 4. But that comes out nicely, doesn't it? So the next value I'm going to choose will be 4. Because radical 4 comes out as 2. So f of 4 equals radical 4 equals 2. So obviously the next value then that would actually be nice would be the next thing that has a nice square root. So 9. Radical 9, of course, is 3. Next would be 16, because radical 16 is 4. So the largest value I have here is a 16. I don't know if I got 16 spaces here. 4. Okay, barely. So I'm going to start way up here. And since none of these are negative, I'm not going to get any x values to plug in that are negative. Over here, none of my principal roots are going to come out as negatives either. So we really don't need the second, the third, or the fourth quadrant. So when I draw my graph here, I'm going to start and I'm going to come down 1, 2, 3, 4. 1, 2, 3, 4. That's 2 sets of 4. 1, 2, 3, 4. That's 3 sets of 4. 1, 2, 3, 4. And that'll be my 16. And I'm going to go just one space beyond. Because my graph does technically extend down into the negatives, but I'm not going to use them. So I'm just leaving one space open for them, and I'm not worrying about the rest. So one space open for them, and that's it. Now, I'm going to do the same thing here for the negatives, and then come over 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I hope I counted that all out right. So I'm just going to focus on the first quadrant. Plot my points. 0, 0, 1, 1, 4, 2, and then 6, 8, 9, 3, and then just to double check, 10, 12, 14, 16, yep, 4. And ladies and gentlemen, if you look at these dots, you might recognize this shape as basically being the same as this. It's just on its side. So we have this same parabolic curve, but instead of being our normal parabola going like a U, this one's on its side and it's only half of it. Well, ladies and gentlemen, what if I want to get that full parabola? If I wanted to get that full parabola, I might actually write a normal equation for that. But in order to get it, I'd probably say that y squared equals x. Because to solve this, we'd have to take the true square root of both sides. So y would equal the true square root. So if I made a table of values for this, so this time we did not write it in. function form. Obviously, I plug in 0, I get out 0. 0, the only way that I can square something and get 0 is if it's 0. But if I put 1 in, so if x is 1, what would you square to get 1? Well, I could square 1 to get 1, or I could square -1 to get 1. Likewise, if I put in 4 for x, what would I have to put in for y? What would I have to square to get 4? Well, you could square 2, or you could square a -2. So again, we're going to notice that since we're squaring y, x is never going to be a negative. So I don't need the second and the third quadrants, but if we look at our y values, we do still have the first and the fourth quadrants. So when I make my coordinate plane here, I'm going to come down 1, 2, 3, 4, 5. I'm going to make a little mark here. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. I don't need quite all of it, so I'm going to focus in on what I need here. So to plot my points, I've got 0, 0. I've got 1, 1. I also have 1, -1. I have 4, 2. I also have 4, -2. And so we really do see that same parabola shape from before. So let's get that nice curve. It kind of slows down there as it hits that point there on the left. Now the trouble with this is, unlike our other examples, this is not a function. Remember, ladies and gentlemen, when you have a graph, one of the easiest ways to tell that if it's a function is, does it pass the vertical line test? So if I take a look, is there any place where I can stick a vertical line through the graph and it hits the graph more than once? Yes. So since a vertical line can hit the graph more than once, so it fails the vertical line test. This is not a function. We quickly look at our other examples. If you were to send any vertical line through here, is there any spot where it would hit more than once? No. If we look at our h of x, anywhere where it would hit the graph more than once? No. G of x? Nope. F of x? No. All the vertical lines would hit just once or not at all. So this last guy is the only one who fails. And that, ladies and gentlemen, is our lesson.